Hello, you're welcome to IDC Learning Center YouTube channel. We are going to be doing something quite interesting as we'll be looking at all physics formulas you must know for JAMB exam and their application. Let's look at the first one. What we have on the screen here says one-dimensional motion. By one-dimensional, I mean that the body is moving only in one plane and in a straight line. You are quite familiar with these equations. We call them equations of motion. The first one is V, which stands for final velocity, equal to U, the initial velocity, plus AT, that's acceleration times time. I'm sure you've seen this before. The next one is V squared equal to U squared plus 2AS. You know the meaning of V, the U, the A, and the S. All right. Now the next is the S, which stands for distance, equal to UT. Remember I said earlier that the U stands for initial velocity, plus 1 over 2 AT squared. All right. Let's apply at least one of these formula. Let's see how it works. But it's very important you learn how to use these formulas when it comes to calculating problems that has to do with one-dimensional motion. Let's look at this. If a 15-kilogram ball takes 5 seconds to strike the ground when released from rest, at what height was the ball dropped? It's always good that you bring out your parameters in physics. In this question, they are asking for the height, so we need to calculate for distance. Among the formulas I gave you one for distance, and I said distance is UT plus 1 over 2 AT squared. Again, I'm going to take the question. If a 15-kilogram ball takes 5 seconds to strike the ground when released from rest, release from rest here means that the initial velocity is 0. So if the initial velocity is 0, whatever you use to multiply with 0 will give you 0. Everything here automatically will be 0. So the distance will be 1 over 2 times acceleration. What is the acceleration? Do you have something to say? The acceleration here is equal to gravity. Okay? Because as the ball descends, gravity will act on it. And acceleration due to gravity, G, equal to 10 meters per second squared. So this A is equal to gravity in this question. So this is going to be times 10 times T. What is the time? In the question, the time was given as 5 seconds. All right, but it's going to be square means you repeat it. That's 5 times 5. 2 here 1, 2 into 10, 5. Okay, now to get the distance, which is x, it will be 5 times 5 times 5. Distance will be 125. What is the unit? Meters. This is just one of the applications. You can look up other examples and other questions using the other formulas I gave earlier. The second formula we need to know, or the second aspect before you take your JAMB, is the parallelogram law of vector addition. I'm sure you already know how vector work. We know that vector has both magnitude and direction and is quite different from scalar. So, if this is my vector, okay, now let the magnitude be 15 Newton. If the direction is due east, then this is a vector. We can see that it has magnitude and it has a specified direction, which is due east. Okay, let's look at this line. Let this be a vector, probably vector x. Okay, let this also indicate another vector, which is y. If they both meet at this point O, now I want to draw another line from point X here that will be parallel to Y. Okay, this is parallel to Y. Then another line from this vector Y, which will be parallel to X. This has formed a parallelogram, isn't it? Now they intersected at this point. Let this be P. The diagonal, which is the distance from this point O down to this P, is known as resultant vector. That's how to calculate resultant vector. So now I want you to define resultant vector, which, like what I've done, we need the parallelogram law of vector addition. That's what I showed you. It says that if two vectors can be represented by the two adjacent sides. Now I have the two adjacent sides, the x and y, both in magnitude and direction of a parallelogram drawn from a point, which I did also, then their resultant is a diagonal of the parallelogram. Parallelogram law of vector addition is more than what I have, but this is just the concept. I want you to look it up. It's very important you know how this works before you take your exam. Now you are going to look at Newton's law of motion. The third one here is Newton's law of motion. Yeah, we have the first one, we have force, which is mass times acceleration. Momentum, okay, mass times velocity. Impulse, which is force times time, which is equal to change of momentum. Impulse is change of momentum. Where m is mass and v and u are the final and initial velocities of the body. Please take note of these formulas. As you are watching this video, please jot them down and subscribe to this channel if you've not done so. Please jot down this formula. Now, I want us to apply this formula. Let's solve a question. Are you ready? Okay, so let's look at this question. In this question, the question says a net force of magnitude 0.6 N acts on a body of mass 40 gram, initially at rest. Calculate the magnitude of the resulting acceleration. The force here is 0.6 Newton. So for number 1, let the force, which is F, be 0.6 Newton. The mass in this question was given in grams, so we need to change from grams to kilogram. Remember, 1000 grams make 1 kilogram. To change 40 grams to 1000 to kilogram, you divide by 1000. If you divide by 1000, 1, 2, 3, it will give you 0.04. So the mass will be 0.04 kilogram. I'm sure you know how I got that. Remember, force is mass times acceleration, isn't it? What are we looking for? We are meant to find the resulting acceleration. That means we need to find A. The force has been given as 0.6. The mass is 0.04 times the acceleration not given. To get the acceleration, we simply divide both sides by 0.4. Divide this side by 0.04. Now 0.04 cancels 0.04. 0.6 divided by 0.04. Acceleration will be 15 meter per second square if you punch that into your calculator. It's just an application of um, of um, the third formula, as Newton's law. Let's look at the next question here. A ball of mass 5 kg hits a smooth vertical wall, normally with a speed of 2 meters per second, and rebounds with the same speed. It rebounds with the same speed. Take note of that. Determine the impulse experienced by the wall. I said impulse earlier when I gave you the formula. You can rewind a bit, which is force times time is also equal to change of momentum. Yeah, there was change of momentum. Remember, change of momentum is supposed to be um, mv minus mu, but I'm using mu since the speed is the same. Mu minus, but when it was coming back, for the fact that it rebounded, coming back, it's going to be negative because it changed direction. So instead of just writing mu, it's going to be minus mu because it changed direction, going forward, bounce and return back. Don't get confused. So this will give me mu. Now, minus times minus will give me plus mu, okay, which equal to 2 mu. All right. So 2 times the mass. What is the mass again? 5 kilogram. Okay, and then the velocity is what? 2. 2 times 5, 10. 10 times 5 will give me my answer, which is 20 kgm per second. All right, this is an application of Newton's law of motion. Yeah, I solve a question on force and impulse. So you can still try and look up other questions as well, but this is just to keep you abreast with what you are supposed to know. Now let's look at the fourth formula. Work. Work is an interesting topic in physics. Personally, I enjoy teaching it. It's broad and it's very, very interesting. The formula for calculating work, as you can see on the board, is force times distance. The work W stands for, the F here stands for force, and the S here stands for the distance. Let's just solve a simple work here, okay, to demonstrate how we can apply this formula. The question says, what is the work done on a 45 kilogram box that is being pushed with a 100 Newton force for 5 minutes? In this question, we are given the force on the box and the distance it travels. So we need to use these values to calculate the work done. The work done equal to the force, which is 100 Newton. And then this distance being pushed for 5 minutes, and force for 5 meters, sorry, with a force of Newton for 5 meters. So the distance is 5 meters. Okay, so this will give me the work done is 500 joules. That's 100 times 5. That's all. Well, it goes beyond this. We have other complex questions on work. Like I said, this is just to give you an idea of how to apply this formula, but you can still try other questions. If you want me to solve more questions, do let me know. I won't hesitate to do that. Let's go to the fifth formula. Okay, for the fifth physics formula you must know before you take your examination, your JAMB, is the kinetic energy. I want you to know that anything that moves has kinetic energy. And the equation for kinetic energy is 1/2 mv squared. But if the velocity is 0, what then happens? For example, a rotating object isn't moving left or right, up or down, forward or backward. So the question is, a rotating body now, does it have kinetic energy? We have two types of kinetic energy, as you can see on the board. We have the translational kinetic energy and the rotational kinetic energy. The formula for calculating translational kinetic energy is 1 over 2 mv squared, what we all know as the kinetic equation for kinetic energy. But kinetic energy of rotation, which is the movement energy an object has due to its spine, is 1 over 2, as we can see here. This L stands for the moment of inertia or rotational mass of the rigid body, while this W stands for the angular velocity. So 1 over 2, the mass of the rotational mass, the mass of the rotation, and then the angular velocity squared. Okay, you use this formula for rotational kinetic energy. Let's solve a problem on this. In this question, a body of mass 2 kg is released from a point 100 meters above the ground. Calculate the kinetic energy 80 meters from point of release. In the question, the mass of body M was given as 2 kg. The height from which body is released, the height h, has been given as 100 meters. To find kinetic energy of body at 80 meters from the point of release, of course, we need to use the formula for kinetic energy, which is 1 over 2 mv squared. We know the mass, but we don't know the velocity. So we need to find the velocity. To do that, we go back to the equation of motion and we use a formula that connects distance and velocity, which is v squared, final velocity, equal to u squared plus 2as. Remember, this is acceleration, which can also be acceleration due to gravity. Since the body is released from a point 100 meters above the ground, the initial velocity will be 0, because at the point where the body is released, it does not have a velocity. So if the initial velocity u is 0, u squared, to get v, we have v squared equal to 2as. V squared equal to 2 times acceleration due to gravity in this case, which is 10, and the distance is 80. V squared, we give it 2 times 10, 20. 20 times 80 equals to 1600. To get, since v squared equal to 1600, to get the v, I need to square both sides. This square breaks the square root. The v equal to square root of 1600 will give me 40 meters per second. Now that I know what the value of v is, I can find the kinetic energy, which is 1 over 2 m is 2, v squared 40 squared. 2 cancels 2, kinetic energy will give me 40 squared, 1600 joules. This is just an application of the kinetic energy. The next formula I want us to talk about is the gravitational potential energy. The formula for potential energy depends on the force acting on the two objects here. So for the gravitational force, as we can see on the screen, the formula is potential energy equal to mgh. M here is the mass in kilograms. G is the acceleration due to gravity, which is 9.8 meters per second square, or approximately 10 meters per second square. And the h is the height in meters. Let's come down a bit. The elastic potential energy, which is stored in a spring that has been stretched or compressed, is given as 1 over 2 kl squared. The k is the spring constant and the L is the length of the spring. So once you are given a question like this, these are the formulas you need to get your answer. So the next formula, here we have power. Yeah, in physics, power is the amount of energy transferred or converted per unit time. That is why you can see the formula here, power equal to work divided by time elapsed or elapsed time. Or we can also use this formula, power is energy divided by time. Remember, time is in seconds. And don't forget, 1 horsepower is 726 watts. So questions on power, you are good to go. Let's talk about current. Current is usually denoted by the symbol I. Ohm's law relates the current flowing through a conductor to the voltage V and the resistance. Okay, so that is why we have this formula for calculating voltage, which is current times resistance, or current equal to voltage over resistance. All right, I just want you to know what the V stands for, the I stands for current, and the R for resistance. Here we have power. Electric power is simply the product of current times voltage. If you are given a question on power, you simply have to multiply the current times the voltage. In this formula where we have power equal to V squared divided by R, the power dissipated in a resistor is given by this, which means power decreases if resistance increases. But if power is given as this, I squared, current squared times resistance, it means that power increases if resistance increases. Please take note of these formulas and you're good to go. The next formula is resistance of resistors in a series. To calculate the total overall resistance of a number of resistors connected in this way, you simply add up the individual resistance. Yeah, just add up the individual resistance. Then that is what you need to do to calculate for resistors in this series. If it's the other way, for resistance of resistors in parallel, then you have to go this other way. 1 over R1 plus, add everything and you get your answer. And finally, the formula for calculating relative deviation in physics is mean deviation divided by mean value times 100%. I'm going to stop here. You need this video. Please practice these formulas, share this video, and don't forget to subscribe to IDC Learning Center YouTube channel. Feel free to make any requests. Someone requested for this, you can also make a request yourself. Bye.